Hello, this is the fourth video in the series of programming the simulated ball shooter using state machines and the state machine template that I developed. In this video, we're going to show you some tips and tricks to get your development going a little bit faster, and we're going to build the drive using the state machine actuator template. And we're also going to build a state machine and go over again how to take a state machine that we've built on a drawing and translate that to LabVIEW for our drive. Okay, let's get started. So the first thing I want to go over is a reminder on how to do a quick drop shortcut. So now that we are starting to build our templates, we're going to become a little bit more proficient. So we can use the quick drop shortcuts to help us quickly place items and get them wired quickly. So what I'm going to do is I'm going to open a new VI, and in our templates we tend to use these bundle and unbundle by name a lot, right? And we have to do some multiple clicks here to get those bundles and unbundles on here. So let's create a quick drop shortcut, like using only two keystrokes to bring these up for us. Alright, so we're in our block diagram. We're going to hit Control Space and we're going to go to Configure, and we're going to go to the block diagram tab here, and we're going to first bring up our unbundle by name, B-U-N-D. So we need to find it here in our diagram shortcut object. You can see there's the whole list of all the things you can find, but the diagram shortcut will try and auto find for you. And I want to set a shortcut here for my unbundle by name. So my shortcut for that is cluster T or cluster V. But you can create any one you want. You can make it a UB. If you really want to be fast or whatever, it's best to use keys that, if you're assuming your mouse is right-handed, you want to use keys that your left hand can touch. So C and V for me are all my left hand can get to. So you want to avoid the keys further on the right hand side if you want to be really quick at this. So my unbundle by name, I'm going to say is CV, and I'm going to then add that. I'm going to do a bundle by name, and I'm going to call that CT. Again, you can do whatever shortcuts you want. It'll help you remember. And the other thing we use a lot is a case structure. So I'm going to add case structure to my list. And all my nodes or cases or structures, I use one letter. So I'm just going to make case structure C. And I'm going to add that. And the other thing that we drop a lot is a numeric constant. So let's look up numeric constant, and I'm going to use the number sign, which will be 3, numeric for number, C for constant. I'm going to add that. Again, choose whatever keystrokes will make you remember, and if you really want to get good, then I would use only left-handed keys. Alright, so let's do a quick Control C B, Control CT, Control numeric constant, Control C. There's my case structure. So saves a lot of time, a lot of palette clicking. You probably want to do these shortcuts for items that you use a lot. After you get up over 10 or 15 of them, you start forgetting what you used. As you can see from my palettes, I have a whole bunch of shortcuts because I do this a lot. So I can do things like array size, array index. All my arrays start with A, and so on. And the other thing I want to show you is palette sorting. So when you do use palettes, you can sort the palettes to your liking. So if you bring up the palette and you hit the stick pin, and you're able to then take and drag and drop these palettes around. So the one that we use a lot is select a VI. So I like to bring that up to the very top. So it's always, if I don't have any of the default items or the ones that Lab uses a lot, I immediately go to select VI. And I order these other ways too. The ones that I tend to use a lot get pushed to the top. So then after you're done, if you then click on the X, now you'll see every time I open the palette, my select VI is right there. If you have VIs that you don't really know where they are, but you found them once and you're happy that they're there, you can actually add them to your favorites, and then you can go to your favorites palette as well. Okay, so let's build the drive for our ball shooter simulator. Okay, so as a reminder, if you go to this bit.ly link, you will go to my Google Drive where I have all the demos, and you're going to want to download demo 2, because that's the demo we're going to start from. Okay, so let's copy our demo 2, control copy, control paste. Okay, we're going to begin by copying our actuator template. So we're going to go to our templates, and we're going to go to actuator library, and we are going to save as. And we're going to call this our drive. And we are going to save it, create a folder in our systems folder, drive folder. And save in that current folder. Okay, so now we have a drive folder with our drive in it. Our drive library is in here. And let's open our actuator loop. And first thing we do is make an icon for all our VIs. So we're going to right click on our drive, go to properties. And make a new icon. Okay, let's go into our drive and add our drive VIs. So let's look in our robot main. Let's see how they do the begin. They open the drives. So there's our drive code. And so let's bring up our template here. Shrink it down so we can see both windows. So I'm going to copy this code, Control C, and I'm going to come over here and paste it. I'm going to remove this guy. And I'm going to create a constant for these wires. And if you double click, it's a big constant. If you double click on the edge there, it'll shrink it down to an icon. And then remember to give it a label. And then we can replace this placeholder with our reference. And then we can delete this code and bring our reference in here. So if you're wondering where this is in our WPI library, I'll show you. It's here in WPI lib. We go to robot drive. There's drive open 2 motors, drive open 4 motors, arcade drive and tank drive and holonomic drive are the different drives that you can have, that you can control a robot with. And if you have a different one than these, you can kind of make your own with these motor VIs. Another thing that is in a lot of robot code here is this safety config. So if you have a robot and your robot is driving and your RoboRio loses communication with your driver station, the last command that robot got was drive forward. And if you lose communication, you're no longer giving it stop commands or anything, and the robot just continues to drive forward because that's the last command it got. So these safety configs or whatever, they require that a signal gets sent to the drive or to the motors at a periodic time. And I'm going to create a constant here to show you the default is 0.1 seconds. So 10 times a second you need, or this VI or whatever, this state machine needs to tell the drive that needs to tell it a command. If it doesn't get a command 10 times a second, if it misses, then it will go into safety mode and shut the motors off. So if you driving your robot and you lose communication and 1/10 of a second later you don't send a command, the motors will shut off. So this causes a lot of it's safety. It helps safely shut your motor down if you lose communication, but it does cause a lot of errors in your driver station. If your loops go too slow and they're not able to keep up, you'll see a lot of watchdog errors. So that's what that VI is for. We're going to leave it in because we're going to set our loop to 50 milliseconds. So that drive should be updated 50 milliseconds, twice what our requirements are. If you want this to not be so stringent, maybe make it 200 milliseconds, maybe make it 500 milliseconds. That'll allow you to run your loop slower. All right, so we got our startup. We're doing 2-drive motor. We're saying the left motor is inverted and the right motor is not. And our motors are connected to PWM0 and PWM1. So let's do a close. So let's go here. So I'm going to shift right click, shift right, control shift E to get to the, and we're going to open finish, and we're going to look for any drive code here, close. There's our close code. So we're going to close our drive when we're done. Get our reference and wire a reference to our closed drive. And I'm going to save all. And I'm going to close this. And I'm going to open teleop and look at the drive code there, see if they do anything special. So it looks like all they do is they just run the arcade drive. Okay, so it looks like I need 2 inputs, an X and a Y input to my arcade drive. I'm going to drag this over, copy it, and wire up the references. All right, and then I need to add 2 constants to my cluster. One will be drive X and one will be drive Y. So I already have some placeholders here. I'm going to call this drive X, and I'm going to control drag to make a copy. I'm going to call this drive Y. And remember to wire those into my cluster so that I can unbundle them later. And save all. Okay, so I'm going to come over here. We're going to need to write into our arcade drive. We need drive X and drive Y. placeholder. And the other thing that they do is, you can see they take an array, the motor array out, and they write it into this robot motors network table. So we need to then create in our global variable that this VI writes. We need to create an array. So I'm going to create a constant here and just copy it or cut it. And then I'm going to open my global variable that this VI is responsible for writing to. Open front panel. And I'm going to paste that array here. So right now these two variables, so we still want cycle time for every loop so that we can monitor our cycle time. These other two we're not going to use, so I'm going to delete those to get them out of the way. Now remember, we need to support this naming convention. So we want ACT, our library name is drive, cycle time, and the same with this. These are motor values, but ACT, so actuator, drive, motor values. So these are the two values that the motor drive ACT loop, actuator loop, writes. All right, so I'll close this now, and let's fill those in. So select this and delete it. So I also want to add my output array to my cluster so I can bundle it in. So I need to add that as well. So I'm going to come over here, and I think I still have it. I can paste it and create a label. Call it motor values. And then we're going to bundle that into my cluster. My cluster contains everything that this loop uses, all the data that it uses. So I'm going to go over here and unbundle motor values and wire that across. You don't need this anymore if you don't want it. So if you want to get rid of it, we can right click and we say remove sequence. Don't use this one. Don't do remove and rewire. It'll mess everything up. So remove sequence. So x-axis, y-axis. So this one is our motor values, and so we're going to wire that into our global variable. And this one up here is our cycle times. Okay, so we have written out all of our outputs. So let's go and look at over here at our command global. So this is the global that our actuator loop reads to give it a command. All right, and so I'm going to open this up. The command global is kind of put inside a cluster because typically commands are for actuators. You can have lots of different modes. So our drive mode, we're going to start with two modes that we're going to command it. We're going to command it to just stop, or we're going to command it to run X and Y values from teleop. Okay. So those modes, we have this list of things that we want to command it. So a good tool to create a list is an enum. So we're going to create a new enum, and we're going to call that our command mode for our drive. So we're going to right click and we're going to bring up a enum, and then we're going to open the type def or make type def, open type def, and I'm going to quickly then create an enum. Okay, I'm going to save it with my systems drive folder, and I'm going to label it as an enum drive command. Click OK. All right, now let's find it on the project. So Control Shift E, and we'll see that we created it, but it's not inside my library. I think I would like it inside my library because it's going to be travel around with all these other VIs. So all you have to do in the project is just grab it. So let's notice the name first. You can see it says enum _ drive command.ctl. But once I drag it into the library, highlight, release, now you see it's inside the library. You'll see the namespace of this changed to drive actuator library enum drive command CTL. So it's telling you that it's inside this library, it's part of that library. Well, if it's part of that library, we can auto create the icon, the header for it. So I'm going to save, and we're going to go to our library and do properties. And then if we click this apply icon to VIs, it'll apply all that icon to all our VIs, including the one we just put in there. So now if we open our enum drive command up, we'll see that we have the drive icon. But let's clean it up a little more and fix the icon. So we're going to just create a yellow border here. We got to go to our layer, our default layer, and make sure we remove that. And then let's put some black text in here that will describe what this is. Enum drive command. And then save all. And close. And I'm going to label this drive command. Actually, just command because I know it's in the drive. I already know it's in the drive cluster, right? And then I'm going to bring this. I'm going to cut it. Control X. And then I'm going to open up this cluster, which is also a type def. Open type def. And I'm going to paste that new enum that I just created in there, my cluster. And we'll delete these other two because we'll add some other stuff later. So we have our stop and our command, our teleop command. So we can tell the drive to stop, or we can tell it to drive like teleop. So what else we want to add to this cluster are the teleop X and Y commands that we're going to, that our commander, either our teleop or our autonomous, are going to tell this VI what to do, how to drive. So let's create a get a numeric constant, and instead of calling it X and Y, we want to do this as the drive. So our X is left, right, and our Y is forward, back. So the naming sometimes helps us remember. I mean, X and Y don't mean as much as left, right, forward, back. That's really what the drive is doing, is turning it left, right, or moving it forward, back. So we're going to apply changes and save all. And our icon is already made for this one, so we don't have to do anything with it. So whatever the commander is, so teleop or autonomous, If they want the drive to run in teleop, they will select the command mode to be teleop, and they will give it a left-right value and a forward-back value. If they want the drive to stop, they simply give it the command to stop, and then the drive will ignore these two values and just stop. Turn all the wheels, turn all the motors off. So that's the two commands we have now. Later, we're going to want to add some more commands to tell it to track to a compass location or to track to a distance location. So the reason we create this enum is so we can later create more commands that the drive can adapt to. All right, so I'm going to close this. So we're in our global variable. We make sure we name this correctly. Command actuator drive data, and save all, and close. All right, and there's our drive data, and you see that in our cluster we already had this as a type def. We already had the drive command cluster, so when we updated it here, and it updated inside our global variable, and we just had to select it. Okay, so we have our command cluster coming into our drive, telling it to stop or run teleop. And then we have our outputs, our motor values going to our output globals, and our cycle time. Okay, so now that we have all our drive VIs in and our global variables set up, one more thing we need to do is display these on the front panel. I'm going to create an indicator here so we can see our inputs and what values we're setting the drive. And if you wanted to, we could create an indicator here as well, saying what our motor values are. And then let's arrange those so they're easier to read. Here's our drive X and our drive Y. And here's our input cluster. Like so. And we're going to save all. Okay, let's go back to our block diagram. Now we can start working on the state machine. So it'd be really nice if we drew a diagram of our state machine, and then take that state machine and then kind of translate it into our states and our actions. So I showed in the last video how you can take the LabVIEW decorations and kind of build a pseudo mock-up kind of state machine. I've discovered another ones using the Google Documents drawings that came in pretty handy. So I'm going to open my Google Drive. And I'm going to go and create a new, I'm going to go more, I'm going to create a new Google drawing. So Google Documents drawing makes it pretty simple to build a pretty nice looking state machine. So if I select circle, I can create circles, and if I double click in here, I can put some tagging a little bit wider so it fits. And the thing that I like is this align. You can select this curve connector, and it allows you to draw our lines even back to itself. And then I go back to the arrow tool, and I can kind of size these and make them as loopy or as big as I want. And the other thing is you can select the end, what the end looks like. So I can actually put an arrow on the end there, looking just like the state machines that I showed in my videos. And then I'll just drag some text boxes on here. for actions, and need to size that a little bit smaller. And I'll usually color actions pink, personal preference. And I'll bring another text box, and this will be my decision making notation. So I will say something like command equals stop. And I usually color it yellow. Shrink it down a little bit. Color it yellow. And then I'll usually put my logic notation saying this is the reason I've gone to this transition, command equals stop, and this is the action I do before I come back to start up or whatever. And then you can actually save this drives state machine and put it in your shared drive. So I'm going to build the state machine for the drive, and then when I get back I'll show you what we do next. Okay, so here's how I want my drive to work. So we have 4 states: startup, stop, direct drive, and shutdown. And we'll go to startup, no condition. We immediately use the break action. So I also have a break action, I have no actions, and I have a direct action. So remember, we want to make the states sound like nouns, somewhat like nouns, and we want the actions to sound like verbs. Okay? So then we go into our stop state, and then we have 2 conditions to leave the stop state: command equals stop, in which case we run the break action, and then we come back. If command equals teleop, we don't do an action, and we go to direct drive. In the direct drive state, we look at command. If command is in teleop, we do the drive direct action, and then we come back to drive direct. If our command equals stop, we go to break. Actually, this is an error. If our global stop equals true. So if our global stop equals true, we go to the break action, and then we go to the shutdown state. And I also would like if my stop sees the global stop, I want it to also jump to shutdown. So I'm going to add another curve connector and place it here, and then go to my arrow tool. First I want to give it an arrow at the end. And I'm going to resize it like so. And I'm going to take this, copy, and paste it. And I just drag it over here. So if that's global stop, I also want to grab the wrong one. So I want to break. Okay, so I got the state machine the way I want it. So you could download this to your computer and then copy it and paste it to your block diagram. But there's one handy tool if you're using Windows called the snip tool that allows you to just copy whatever's on your screen. So the snipping tool, open that up and you click here, new, and then I'm just going to draw a box around my state machine. So, and then the snipping tool gives you this window, puts your diagram in it, and you can just right click inside the image and say copy, and we'll put it on your clipboard. And then I'll close this without saving, and then I'll close my browser. This is already saved. I'm going to close my browser, and then I'm going to go to my loop, and then I'm going to paste my state machine right in my block diagram, so I have a reference of what I was thinking, or whoever the programmer was that developed this. You can see exactly what he was thinking with this state machine. May need to get a little smaller so it's not so unwieldy, but as long as everything's still readable. There's our state machine. So now that we have our state machine diagram, it'll help us build our states and actions. So let's build, make sure that we have our 4 states: startup, stop, direct drive, and shutdown in our state enum. So our state enums just sit over here just as a constant for like reference. So let's bring them over here by our state machine. Okay, and here is our state enum. So let's open that typedef, and let's edit our items. And I want to start up, I want to stop state, I want to shut down state, and we want to direct drive state. And size it so that everybody shows up. File, apply changes. File, save all. Alright, and let's do the same for our action enum. So our actions are break, no action, and drive direct. So right click on here, open typedef, edit items. So no action, reset time and reset all, we'll keep those in there because those are kind of ones to have, good ones to have. So we also want a break and a drive direct. And trying to make them verbs. And then make sure everybody sees. And we're going to call this my enum action. Apply changes and save all. Okay. And then we have some grayed out items that we need to fix. So we're going to find a grayed out one and say review and update typedef. Gives us a list of the ones that it doesn't know what to set that action as. So we'll say action A is going to be break for both of those and apply changes. Okay, so let's go to our action case structure and let's build the action for every one of our different actions. So no action, we're going to do nothing. Reset time, we're going to take the current time and put in the start time. Reset all, I guess we could do this. We may want to do something later. But we're going to just say turn the two drive. So we're going to write here to our drive X and our drive Y, which will drive. So most of our actions are going to be that have to do with the drive mode or the command mode are going to have to do with setting the X and the Y drive. So a break, the break should be the same as reset all. So I'm going to delete this case and I'm just going to duplicate my reset. So I want my break, I want to set both X and Y at 0. That's how I want to stop my motor drive. And the last one is drive direct. So for drive direct, we're going to write the X and the Y value up to our motor, but we're going to read those from our command, our actuator input, should name that more, our left, right cluster goes to X, and our forward back cluster goes to Y. So when we are in the direct drive action, we take from our command cluster, let's go name that better, because instead of actuator input, let's call it command data. So, right. So from our command data, that one of our commanders writes, in direct drive we take our left, right, and we write that to our X, and we take our forward, back, and we write that to our Y. Okay. But when we go to stop or we hit the brakes, we write both at 0, and we don't care what our left, right, or forward, back are. We're there to stop, and we send a 0. So those are our two actions. Right. So we have all our actions built up. We know what they do. So now we need to go to our states and kind of follow our state machine. So each state looks at some kind of criteria to determine what the next state is and what the action is that it needs to do. All right, so we will start at startup, and we will look here. So we have some more gray ones that we need to fix, grayed out ones. So I'm going to right click and say review and update. Idle is going to be replaced by stop, and we'll apply those changes. So we're at our startup state. Our startups doesn't look at any condition, and we immediately call the brake, and we go to the stop case. So we'll head to the stop case, and we will call brake. All right. Now if we go to our stop case, there's our stop case. Our stop case looks at our command coming in, whether it's stop or whether it's teleop. All right, so I'm going to remove this code. Oops, we're going to remove all this code right here. Just template code to assist, but if it's in the way, we can get rid of it. So we're going to get our command data, command, and we're going to bring up a case structure. And we're going to wire that into our question mark. So if it's teleop, okay, so if it's teleop, we're in our stop case. If it's teleop, if our command it's teleop, we do no action, and we go to direct drive. Okay, we're going to do the teleop state, or the teleop command. We're in the stop. We're in the stop case, and we look at our teleop command, or we look at our command data command. If it's teleop, we want to do no action. That's our action, and direct drive should be our next state. Okay, so we're going to create a constant, and we're going to drag it inside here. Now you'll notice that LabVIEW is doing something weird. It's making double tunnels, so I don't want it to do this auto wiring for me, so I'm going to hit the W key, tell it to stop doing that, and then just wire myself direct drive, and I'm going to do the same here. I'm going to drag it in, and again it's doing something I don't want it to do, so I'm just hit the W key, and still created an ugly wire that we can delete. But alright, so we go back to teleop, see teleop, I do no action, we can do a no action, and go to drive direct. If I see a stop command, I'm going to get rid of the default. I can create a constant here. We return back to the stop state, and we do the break action. And let's save all. Okay, so that was our stop state. And we look to see direct drive is also going to look at the commands, and this code is going to be similar. So I'm going to duplicate this, but first I'm going to go, I'm just going to duplicate this, make this direct drive, and I have most of the code's already written for me. I don't have to go and rewrite it. So again, if teleop, if I'm in direct drive and my commander says to run teleop, I do the direct drive action and I return back to the direct drive state. And if my commander tells me to stop, I do the break action and I go back to stop. Go back to stop and do the break action. It's already done for me. And let's save all. And finally, we'll do the shutdown action. It says that if we get into the shutdown state, we immediately go to break. So this doesn't quite follow. We should actually have another arrow here going back to shutdown saying I always just go to the break. So this state machine doesn't quite follow what this reads because our global stop trumps everything. If our global stop is ever read true, we immediately go to shutdown. So every single state here would immediately go to shutdown if they saw the global stop true, and they wouldn't call the break. So I need to go back and fix this state machine to more represent what my code is. Okay, so I went back to my Google drawing and updated my state machine to better represent what's actually happening. So again, if the stop or the direct drive sees the global stop equal true, they immediately jump to shutdown, and then shutdown continuously calls itself and the break each time it does call itself. So this represents now better what my diagram represents. All right, now let's go and replace all the old drive code with the new drive code. All right, so let's start here at begin. And now we can remove this drive code because we do it in our loop. Close this. And we go to teleop. Teleop, we are going to take these two values and we're going to write them to our command. Remember, teleop is our commander, so we're going to write that to our command global. So let's find that in our project. So Control-Shift-E to get to our project. Here's our drive. We are looking for our command global here, and we're going to drag that onto teleop, and we're going to make it a write. And we're going to create a constant so we can bundle things in by name. So we're going to create a bundle by name. So remember our shortcut, Control-C-T, or whatever one you used. And I'm going to create a constant. So my command will be teleop. Move this up a little bit. And if I command teleop, I need to give a left, right, and a forward, back command value. So left, right would be this value, and my back, forward would be that value. Okay, and I need an array here to write to this network table. So that would be the data that the actuator loop writes. So let's go find that. Control-Shift-E. We're looking for the global actuator data out because it writes the motor values. And we're going to change it to a read, and we're going to select the motor values. Now I can delete all my drive stuff. All right, and go to finish, and get rid of any drive code that's in there. And I think that's it. So now you can see that my drive code is now commanded by this command cluster. So if I wanted to create like a break button, I could unbundle the button. Let's actually do this. Let's make break button number 4. So I'm going to index my array. So this is my button array. And I want to look for button number 4. And I'm going to control drag here and make some space. Holding down the control key and just dragging. And then I'm going to hold the shift key to move it orthogonal. And I'm going to add a case structure around this enum. So control space C for case structure. That was a shortcut I made. And when this button is true, I want to stop. Send the stop command. When it is false, I want to send the teleop command. Okay, so let's run robot main and see if this works. So we're going to go back to our project, Control-Shift-E, and we're going to open robot main, and we're going to open our driver station. Just over here. Robot main. Driver station, and let's see, what's button number 4? I think it's Y. 0, 1, 2, 3, 4. 4. So it is the left bump switch is number 4. So that should be my brake. All right, so let's test that out. Run robot main. It should bring up the simulator. Oh, and I get an error. So let's tell it to stop. We see you went to time tasks and showed us that we still have some drive code that we need to get rid of. Okay, I'm going to get rid of this drive code, and I'm going to have to get rid of these broken wires and these shift registers that I'm not using. And this whole entire loop we're not using, so we're going to get rid of that. There's still stuff in this loop, so we'll keep it until we get everything replaced. And then we're going to file, save all. Close these down. And let's try again. First, let's make sure we shut down the simulator. Sometimes it'll lock up if we don't shut it down correctly. So LabVIEW actually did crash. The simulator crashed LabVIEW on me. So I'm going to try it again. I'm going to open robot main. And I'm also going to open my drive loop so we can do some debugging. Systems, open drive loop, actuator loop, and bring up the block diagram on that. Find my robot main here. And let's run it. Have my driver station open so I can enable. Let's zoom in on my robot and let's see if he drives. Move forward. Okay, what did I forget? So we're going to stop the simulator. And I forgot to put my loop in my time tasks. So let's go to time task. Periodic tasks. And move our loop into our time tasks. And let's open robot main again. Make the screen a little bigger. Bring up my driver station and enable. Now let's see if it'll drive. Driving forward and turns left and turns right. Okay, so I'm going to drive and then I'm going to hit my stop button. See, it brakes to a stop. And I release my brake. So we can see that I show my USB button. So this is my brake button right here. So I'm going to go full blown backwards. Then I'm going to hit my brake button and it stops. Despite me still trying to go full backwards. And brake. So my brake is working as I expected. So let's walk through. Here's our loop. Let's walk through that and just show and see how that works, right? So we're in execution highlight. I'm going to put a stop here. So I'm going to shift right click. I'm going to grab my pause and I'm going to put a pause right here. You see it? Once it got there, it kind of stopped. And then we're going to execution highlighting and just kind of watch it. So our state we're in is direct drive. Let's pause it so we can kind of step. The command that we sent, that teleop is sending, is teleop command. In teleop command, we set the next state to be direct drive, and we set the action to be drive direct. Okay, and we open, or we go jump over that, get back to our action loop. We'll step into that, and we'll do direct drive. And we will take our left-right commands and write them to X, Y. And then we are done. We only set one action, and then we set our XY drive to arcade drive. Alright, and just let it go and come back. Then we write all our global variables. So now I have the button pressed in teleop, so teleop should be telling it to stop. So I'm going to step over, step into my state. My state is still direct drive. Step over, step into. So you see now my command is stop. Teleop is sending the stop command. So the next state I set is stop, and the action I set is to brake. So we keep stepping over that. And we step into this, then into here. We set our X and Y to 0 for the brake. Write our outputs. Just let it go from here. And our next state that when we come back to our next state, it should be our stop state. So we write all our outputs. And we come back around the loop, read our command. See that stop is our next state. And I'm going to take the pause off, so I'm going to hover over till I see the white, which means I'll remove the pause. I'll remove execution highlighting and let it go back to doing what it's doing. And then you should still be able to drive, and then slam on my brakes. Okay, so that completes this video showing you how to build an actuator using the Statemachine template and all the things that you need to do for that. In our next video, we're going to add the agitator and the ball shooter and the ball scoop for a quick review, and we'll probably go through those quickly, and then we'll start adding special drive functions like tracking to compass heading and tracking to distance sensor. So we'll see you for the next video.